Hi everyone, and welcome to the tutorial video for version 0.5.0 of Grid Singularities D3A. I have a list of new features to go over with you today. First, I'll start by telling you that our Chat with Us icon now connects you to our Grid Singularity community Slack. So if you'd like to join us there to discuss some of the simulations you're working on and ask questions, please join us at our new Slack address. In this version of the D3A, we've added the ability to set a constant-based grid fee. So in our last release, we had the percentage-based fee, and now in the settings page for your simulation, you can choose whether the grid fee will be the constant-based value or the percentage-based value for your entire simulation. And then when you go for each area, you'll be able to turn the grid fees on, yes or no, and you can type in your grid fee here. So if you pick percentage for the entire simulation, you'll see percentage units here. And for now, you can only set one type of grid fee for the entire simulation. We're working on a good grid fees example to show you the impact that grid fees can have on a community simulation. So once we have that done, we'll publish it as a public example simulation for you to look at and make another tutorial video around that topic. Next, we have the KPIs that we have released in this release. And so those KPIs are the self-sufficiency, self-consumption, and energy peak percentage KPIs. So I'm going to run through those with you, looking at our community as a service example. And this is the same example that we presented at Event Horizon last year, where we have 5 houses, and each house has load and PV. So in the first version of the simulation, we just have loads. In the second version, we added PV to each house. And then the third version, we added energy storage. So in this example, if I was looking at the impact of adding PV to the simulation, I run the simulation, and then I can see some of the parameters that we've added, which is the self-sufficiency and self-consumption. So these parameters are presented as a circle or a pie chart, and it is graphed for each area in the simulation. So the self-sufficiency and self-consumption are standard KPIs in the industry that we've introduced to the D3A, and we have the definition here. So let's look at the community example. It looks like simulation is now finished. So for the community with PV, it has a self-sufficiency of 30.8%. And so that means that the community as a whole has 30% self-consumed energy divided by the total energy demanded. So when we look at the demand of all the loads in the community, that gives us the denominator, and then how much of that energy was consumed, was actually produced locally in the community and then consumed. That's our definition of the self-consumed energy. And this is the standard definition. We have more documentation related to this on our wiki, which you can access by going here to documentation, and you can read more about this. And then for the self-consumption, that's the percentage of self-consumed energy divided by the total energy produced. So this is how much of your production that you consumed yourself, and this is how much of your demand that you produced for yourself, that you consumed from yourself, basically. So we've added these parameters to our simulations, and you can see here, for the 5-home community, the community is not really consuming that much from itself, as we can see in the self-sufficiency. And because it has a lot of PV production, a lot of it is being exported back to the grid. And we can see that here in external trades. So looking at this graph, we look at the external trades from the community, and we can see that a lot of these at the top here, I guess when we look at a lot of the PV production is being sold back to the grid. So then the second or the last KPI that's been really interesting that we added is the energy peak percentage. And so this KPI helps us see if how the peak consumption or the aggregate consumption, imports and exports from an area can change over time compared to a baseline. So in this example, we're looking at the community that just has PVs, and then we want to see if when we add an energy storage, maybe it would help reduce one of these peaks. And so the energy peak percentage is a KPI that would help measure that. So we've added this new feature here called peak analysis, and this is a switch that you can turn on for this energy trade profile graph, and it's available for every area. So when we click peak analysis, what it does is it filters this graph so that we only see the external trades, and then it actually deletes the external trades. So then we can just see the aggregate net load imports to the community and exports. So I'll turn this on. So now we can see the positive axis is the net imports that the community has bought from outside the community, and then the negative is the net exports. And then we've calculated automatically what the peak is here. So here's the peak imports is 2.052 kilowatt hours, and then the exports is 0.085. So I'm going to write down these numbers so that I can enter them in the energy peak percentage KPI in order to measure if the next simulation I run will actually improve or make these numbers worse. And so we want to see if by adding an energy storage, we can reduce some of these peaks. So for the grid, that contains everything in the grid basically. So there's no there's no peak analysis for this because you don't really have exports since the entire grid. So we have the peak analysis turned off for that, but for every home, for example, you can see the self-sufficiency, self-consumption, and then also the peak analysis can be turned on and off for every home. So you can see how much the home is consuming from the external trades and how much it's exporting. So let's go back and look at the example where we've input those baseline values. So it's this example. So then what I've done in this example is I have the same community, I've added the storage, and then I want to see the impact the storage has on the peaks of energy flowing in and out of the community. So I go to the community area and I can set these parameters. So grid fees we're not using here. The transformer capacity is another KPI where you can just set the import and export limits of the transformer for the energy flowing in or out of the community. And this just plots as a line on the results graph, so I'll show you that. And then the main KPI is the energy peak percentage. So here I type in the numbers that I made a point to remember in the previous simulation. So in the simulation without the storage, I wrote down that the peak was 2.052 for the imports and 0.85 for the exports. So I entered these numbers here to see what is the change compared to these baseline numbers. So I'll save here and then run this scenario. So it's still plotting, but we can start to look at the community below. So here, when I turn on the peak analysis indicator for my community, I see a lot of lines. And once it stops loading, we'll be able to see what these different numbers are and what they mean. Okay, great. So now if I hover here, I can see the dotted blue lines say transformer input limits, transformer export limits, and those are the lines just plotted that relate to the import and export limits that I typed in. So it's just a visual indicator that can help the user see, okay, at this point, I would go beyond the capacity limit for the hardware that's connected to this community. So in this case, it's just a line to show if the capacity would have been exceeded in the simulation. And then we have the dark blue line is the baseline peak imports and baseline peak exports. So for the baseline peak imports, you can see it says on the tooltip, it's the 2.052 kilowatt hours, and the exports is the 0.58 kilowatt hours. And so that shows the baseline of where the peaks were in the previous simulation that we just ran. And then the simulation automatically calculates the current peak imports and exports and gives you that value. So we can see the current peak import is 1.618 kilowatt hours, and the current peak exports are 0.237. And then we see the energy peak percentage KPI calculated. And so this percentage shows what percent of the baseline imports is the current value. So for the peak imports, the current value is 78.9% of the previous value. So since it's less than 100, we know that the current value is less, which is good. So it's 78% of the original value. And then the exports is 27% of the original value. So that's a major decrease compared to the baseline that we had. So this is really interesting, and this can show the impact of adding a storage or grid fees to a simulation and seeing the impact of one baseline simulation to another simulation. And if we go to other areas, we can still click the peak analysis to see what the current peak imports and exports are. Great, so that's the 3 major KPIs that we've added. Some other minor features is on the results page, we have color-coded the totals and the energy bills. So previously we had some negative numbers here, and so a negative energy meant that the area or device was producing energy, and then consumption was positive, and then same with pricing. We had the price that was paid was positive and the profits were negative. But here we see it's a lot easier to just make this color-coded. So the bought numbers are blue and the sold numbers are purple. So you can see that if an area is net purple, it has sold net, it has net production, and it has a net profit, right? And if it is bought, if it's blue, then it has a net consumption of energy and a net paid. So this is a great way to quickly interpret some of the values in the energy bills. Another minor thing we added is, or it's not minor, it's just minor to see, is we've increased the node count to 1,000 nodes. So this is really great. You can make much bigger simulations, more complicated simulations. And this is to prepare us for the hackathon, where we plan to run much bigger communities with 25 homes and maybe multiple communities. So you can use this to make bigger simulations. And then another point that I missed mentioning on the results page is you can filter the graphs. So we have this charts visibility feature. You click here and then you can click which graphs you want to be visible. So by default, all of the graphs are visible, but if for some reason you only want to see a couple graphs at a time, we can deactivate a couple of graphs here. And then we see that the energy availability, cumulative trading, and energy pricing are the only graphs visible. So this might be helpful for certain kinds of presentations that you give, or which graphs you prefer to see. And this also applies to devices. So if you look at the load for home 1, we can also select if we just want to see the energy bills or if we want to see both graphs here. One other feature we've added is you can see the status of a running simulation. So going back to the projects here, if I start running this simulation, I can go to my projects and I'll start to see a status bar that shows the status of my running simulation. Okay, maybe we can show this in the collaborations. So that was the next step. Yeah, the last feature is we finished the collaboration scoreboard. So I'll make an example collaboration from this simulation, and I'm actually logged in as an exchange operator, so this isn't something a normal user can do, as we explained in our last tutorial video, the different types of roles that we have. But following the hackathon, we're going to open up the D3A so that every user can run their own collaborations. So I'll make this into a collaboration. And yeah, we did a walkthrough of the collaborations in the previous video, but and we showed here, you have settings, modeling, registry, and scoreboard, and then the results. So in the registry and scoreboard, we have the registry, where as the exchange operator, I can open this simulation, this collaboration for applicants, and then they will apply. And then when I run the simulation, we now have a scoreboard where we can see all of the energy bills and the self-sufficiency, self-consumption, and energy peak percentage for every single area and device. And then we'll have the name of the user that's connected to each of these devices participating in the hackathon. And you can also see, we went over this a little bit last time, but different KPIs can be set for different areas. So it could be to minimize the energy bill, maximize self-sufficiency, self-consumption. So I could set this KPI here, and then when I go to the scoreboard, I can see, what was this area trying to optimize for, and then what was the actual values that this area saw as a result of that optimization. So I'll go ahead and run this simulation, and we'll be able to see the numbers populate here. And so this is just using the internal strategies that were in the modeling page, so we can run a collaboration without having outside contributors. And then let's see if this feature works on the collaborations page. There we go. So I can see the status of the collaboration. So if I'm running a simulation or a collaboration for a long period of time, and maybe it's running pretty slowly, then I can see, how long it has to go before it finishes. So most of the examples we show are just one-day simulations, but if we run something longer for 1 week, that's a much bigger simulation. It'll take some more time to load the results. So now looking at the scoreboard, we can see a lot of the results. So in this case, we can see the bills for each area, and these are cumulative bills. So we can see the bill for the load and PV in home 1, and so that's here. You have the cost for the PV, or the cost for the load, and the revenue for the PV, and then we can see, the PV has a net value it has to pay, and the load has a net value it has to pay, and then the PV has a net value of profit that it gets from selling. So these values added up give you the total values for home 1. So then home 1 has net 1.84 cost, net 0.65 revenue, and then gives them a total cost of 1.19. And we also have penalties. So there's no penalties that show up in this example, except here, and this is because we have this feed-in tariff, which is modeled as a load, so it's getting some penalties. So this is for the hackathon setup. So only if you're working in a collaboration, loads and PVs can get penalties if they don't buy what they were requested to buy or sell what they were requested to sell. So these penalties will come here, and then that will also influence the total energy bill. So if you're trying to optimize the energy bill for an area, these are the parameters you need to consider, right? The costs, the revenues, and then any penalties that are accrued for individual devices. And then we also have the storage, which is buying and also selling. Great, and then the self-sufficiency, self-consumption values from the results page are also plotted here, and the energy peak percentage if this value is activated. If this KPI is activated in the modeling page, then the percentage will show here. So that's sort of a preview for what the hackathon will look like and how we'll evaluate some of the different teams. And we plan to continue developing this feature, so in the future all users can set up collaborations like this and have different people join to work to achieve common goals in terms of optimizing communities. And it's also just a great way for us to see all of the values on the same page together. Great, so that is all the new features for version 0.5.0. Stay tuned for our next release coming in the next about a month and a half. And in that release, we're going to finish working on some of the requirements for the hackathon. So we're going to work on events, and we're also going to work on some other features to improve some of the runtime and set up the example challenges that we have for the hackathon. So if you got our newsletter, you'll see the detailed list of those coming features. Thanks a lot.